For example 3, a train has a scheduled run of 160 kilometers between two cities in Saskatchewan. If the average speed is decreased by 16 kilometers, the run will take half an hour longer. What is the average speed of the train? Well, once again, they both have the same distance. Going from city 1 to city 2 is going to be 160 kilometers, no matter which way you're doing it. The average speed, well, this one has an average speed that I don't know of, x. In the second case, it says that the speed is decreased by 16 kilometers per hour, so it would be x minus that 16. And the time in hours, well, we already know that time is equal to distance over speed, which means that this is going to be 160 over x, and this is going to be 160 over x minus 16. If it will take a half an hour longer than the difference between the slower time, 160 over x minus 16, minus 160 over x, the faster time, has to equal half an hour, or 1 over 2. Which means that my lowest common denominator that I'm multiplying all this by is going to be two x and x minus 16. So I can say that I'm going to have 2x and x minus 16 times 160 all over x minus 16 minus 2x and x minus 16 times 160 all over x is equal to 2x and x minus 16 all over 2. Take out the x minus 16 from the first one, the x from the second one, and the 2 from the last one. And then I'm just going to multiply them out. Well, 2 times x times 160 is going to give me 320x. Minus 2 times 160 is going to be 320. 320 times x minus 16 is going to give me minus 320x minus 5120 is equal to x times x minus 16 is going to be x squared minus 16x. The positive 320 and negative 320x are going to cancel each other out, and the negative times negative 5120 is just going to give me positive 5120 is equal to x squared minus 16x, which means that in this case 0 is going to equal x squared minus 16x minus 5120. Or I can factor this down into 0 is equal to x minus 80 and x plus 64. X could either equal 80 or negative 64. Well, a negative speed does not make sense in this one, so I'm going to reject that solution. And I'm going to say that logically speaking, the speed of the train is 80 kilometers per hour. For example 4, a group of friends go on a 3-hour bike ride together. They ride 15 kilometers with the wind, and then 15 kilometers straight into the wind. The average wind speed is 3 kilometers per hour. So, when they are traveling with the wind, they travel 15 kilometers. When they're traveling against the wind, they travel 15 kilometers. With the wind, their speed is going to be their speed that they're traveling at, and then the wind is pushing them forward, so we'd say the speed of the bike, or the speed of the friends, plus an extra 3 kilometers an hour. If they're going against the wind is pushing back on them and slowing down, we'd say that that is the speed minus 3 kilometers per hour. And their time in hours is going to be 15 over x plus 3 and 15 over x minus 3. And we know that the total time they took to do both of these is going to combine to 3 hours. So I can say that if they went for a 3-hour bike ride, the time traveling with the wind plus the time traveling against the wind is going to equal the total time of 3 hours. The lowest common denominator is going to be x plus 3 and x minus 3. So I am going to state that I have x plus 3, x minus 3 times 15 over x plus 3 plus x plus 3, x minus 3 times 15 over x minus 3 is going to equal x plus 3, x minus 3 times 3. Cancel out by dividing out the denominators. And this means that 15x minus 3 plus 15x plus 3 has to equal, well, x plus 3 times x minus 3 is going to give me 3 x squared minus 9. Or, when I multiply it out further, 15x minus 45 plus 15x plus 45 is going to equal 3x squared minus 27. The negative 45 and positive 45 will cancel each other out. And I'm going to move the x's to the other side of the equation. 0 is equal to 3x squared minus 30x minus 27. It's all divisible by 3, so I'm going to divide both sides of the equation by 3. 0 is equal to x squared minus 10x minus 9. And this I actually can't factor, so at this point I'd use my quadratic formula, completing the square, one of those methods that you're most comfortable with, and find that x is going to be approximately negative 0.8 or 10.8. The negative 0.8 does not make sense in this equation, so we're going to reject it. And we're going to state that the average speed with no wind is approximately 10.8 kilometers per hour. For example 5, to prevent grounding, a cruise ship anchors 18 kilometers away from a river port. To transport the passengers to the port, the crew uses smaller boats. The smaller boats travel 12 kilometers downstream in the same time it takes them to travel 8 kilometers upstream. If the speed of the current is 6 kilometers per hour, write an expression for the speed of the boat traveling upstream and traveling downstream, and let x be the speed of the boat in still water. Well, I can say that the speed traveling upstream means that I'm going against the stream. That's going to be x minus 6 kilometers per hour. The speed traveling downstream is going to be x plus 6 kilometers per hour because the stream is going to push them along. Calculate the time it takes for the small boats to travel upstream from the cruise ship to port. Well, if I know that the amount of time is going to be consistent in both cases, then I can say that the time for one, where it says a small boat travels 12 kilometers downstream, I can write that as 12 over the speed, so the distance over the speed, x plus 6, is equal to the amount of time it takes to travel upstream, which is going to be 8 over x minus 6. I'm going to multiply the x plus 6 into this side, the x minus 6 into this side, and say that 12 x minus 6 has to equal 8 x plus 6, or 12x minus 72 is equal to 8x plus 48. I'm going to subtract 8x from both sides and get 4x, and I'm going to add 72 to both sides is equal to 120. So x is equal to 30. The speed in still water is going to be 30 kilometers per hour, but it wants the time it takes to travel upstream. Well, because we know that time is equal to distance over speed, if it's traveling 18 kilometers upstream, then it's going to give me the time is equal to 18 over x minus 6, but we know that the speed in still water, we just solved that, is going to be 30 minus 6, which means that it's going to equal 18 over 24, or I can divide the top and the bottom by 6, reduce a fraction, and say it's going to be 3 over 4 hours. It takes 3/4 of an hour to travel upstream to port.